So the next item we're going to do is a demo of the boot process. And I'm doing this through our ILO remote console feature. So I'm going to press the power button virtually. So hopefully within just a handful of seconds, the video will be displayed on the screen. So there you go. We press the power button, and very quickly we're displaying information on the screen. You see the progress is at 10%. You see the ILO IP address is available on the lower left. You see the status code on the lower right, and you'll see that status code change at various times. So right now the system ROM is initializing processors. What you just saw was the screen went black because during the early boot process, the system ROM has to actually reset the platform multiple times. And when we reset the hardware, the screen's going to go blank. So we then do come back and pick up where we left off. But that's why you saw that where the screen went black. And if this was the first boot of the platform when it had never been configured, you would see that happen more often. So I think when it's unconfigured, it has 3 or 2 or something of those where the screen will go black. But at any rate, it picks back up. This is everything you're seeing right now. There would have been nothing on the screen in G67. So again, the goal is to tell customers where it's at in case something goes wrong and just give them the impression that the system is actually doing something. So right now we're transitioning to the main boot process. This is where you'd be starting to get video on a previous generation platform. And as you can see, the progress bar is starting to show information. We put on the screen what we're doing. Processor initialization in progress. We're initializing all the processors in the system. That does take a while. You got to initialize caches, do a lot of things. In a second, it will indicate that we're doing thermal calibration. This is something that's needed for power capping as well on blades. It's needed for power provisioning, and the OA gets that value. So now we're running a workload in the platform to figure out what's the maximum wattage this server will do. That does take about 15 seconds. Starting with Snap, with the future maintenance ROM of these platforms, we'll actually have an option to disable that if the customer doesn't care about power capping. So now we've started to display information on the screen. Inlet ambient temperature is measured. Various messages. You see on the bottom of the screen, the values are displayed to hit the function keys. So I meant to hit one of those. Some of the option ROMs actually prevent the ability to hit the key, so that's why it didn't happen. So I may have to do one reboot, but that won't be too big a deal. It's not too terribly slow. So one big change between G6, G7 that you may have noticed is with G6, G7, we didn't display option ROM messages unless you hit a key. With this generation, we actually display the option ROM messages all the time. When we went to G6, G7, it was an unfortunate thing that we were no longer able to do that. Now we've addressed that problem. It does look like I'm going to do one reboot because I missed the function key because, like I said, when the option ROMs run, they sometimes take control of the keyboard, and so when you hit the function key, it doesn't actually show what we wanted. So this should go by fairly quickly. A couple other things to talk about while this is getting back to the point I wanted to show you. Gen 8 systems don't actually boot much faster than a Gen 6, Gen 7 system. It appears faster because of the early video, but the full time is about the same. I have a relatively lightly loaded system here. It's got only a couple of DIMMs. It does have 2 processors. It takes right at 3 minutes to get to the operating system boot, which is about the same as what it would have taken with that configuration on previous generations. If you put more memory in, it will take longer. We've heard from customers that booting faster is something they really want. Gen 8 doesn't really solve the problem. It just makes them feel like it's going faster. We are working on Gen 9 to try to make it actually boot faster. We're working with Intel on some things such as detecting when a processor swapped. So we hope that when we get to Gen 9, when I get to show you a demo for the Gen 9 platforms, which will have quite a few differences, that it will boot faster, which will make it even harder to tell you what we're doing while we're booting, but it should be better for the customer because we'll get up and booting faster. So we're almost to the point where we can hit the function keys. The function keys that are available is you can press F9 to go in RBSU. RBSU is very similar to what we've had in the past. You can hit F10 to go into intelligent provisioning. In previous generations, F10 would actually take you to a system maintenance menu, so it was kind of like a extremely dumbed down and much less useful version of intelligent provisioning, but that's what we had previous generations. It would let you look at some system information. And then you can hit F11, which is a boot override menu. which what I'm going to do in just a second is hit F11 so you can see what the boot override menu looks like, because that's a useful thing if you're in front of a system and you want to force it to boot something in particular, like a USB key. For example, if the USB key is after the hard drives, you want to, I need to pay closer attention because I did the same thing. But I have more to talk about, so I will. But the F11 prompt can allow you to boot the USB key, for instance. You're sitting in front of a system. It normally boots the hard drive. You want to boot a USB key for some sort of maintenance item, for flashing the system if you're using USB key flash. That is available, and I'll show you what that has. Once you go into the F11 prompt, like I said, it'll let you boot any of the targets. You can force it. Basically, it's letting RBSU allows you to modify the boot order, whereas the F11 menu will allow you to override any of that boot order. So you can boot straight to RBSU, intelligent provisioning, USB key, your hard drive, Pixie, whatever you want. And this time I will pay very close attention to the function keys and maybe stop talking for a second so that I will be sure not to miss it. But the one other thing I will show is I'll briefly go into RBSU. It is very much the same and has the same look and feel as previous generations. The menu options, there are several that have changed. One in particular that is worth mentioning is we have changed the USB options quite a bit. The USB, we used to have a lot of options. Now we just can disable boot to the USB ports, or we can disable all the external USB ports. So that is simplified. And there are a handful of other options. So hopefully I won't miss it this time. And I definitely have found a case where something we could look to improve, because I did know that the option ROMs would take control of the keyboard and make the F11 the function keys more difficult to hit. I didn't realize it would be quite this common. So I guess I haven't sat in front of a system just trying to press function keys while doing something else as often. Did I get it? Hopefully I did. Oh, it's not even displaying it yet. There. I made it that time. And maybe part of it is the delay with the remote console. But anyway, this time I hit it. As you can see, the key lit up white. That as soon as a little more progress is done, it will go into the boot menu. As you can see on the screen, there is an error on the smart array. That is not a normal thing. That is just because somehow we messed up some EEPROM information on our smart array on the system in the lab. You wouldn't normally see that. The smart array would normally not take this long to run its option ROM. That's just a real live system in the lab issue, so that's not normal. One other thing to mention while we're waiting for the boot menu to come up is intelligent provisioning. Most customers will hopefully love intelligent provisioning, but we had some feedback. There's a small number of customers who might want to disable it. There were some security concerns whether they're real or not. And so we do have an option in RBSU to disable intelligent provisioning, and if you did, that icon for intelligent provisioning would have been red, and when you hit it, it wouldn't have allowed you to go into intelligent provisioning. So this is a boot override menu. This is because I hit F11, and the goal here is I want to do something to force what I boot. So if my CD-ROM is not higher in the boot order than my hard drive, but I want to boot the CD-ROM, I can hit F11 so that I can force boot to the CD-ROM drive. I think we debuted this functionality in our G6, G7 platforms, but we've enhanced it a little bit, but it was something that I'm not sure that everybody realized exists because we hadn't supported it previously. This will let you boot the drive key, floppies, which not many people will have anymore, the CD-ROM drive. Like I said, it just lets you, it's the same as going into RBSU, modifying the boot order, except it just does it for one boot. So instead of going to RBSU, modify boot order, do what you're going to do, then going back into RBSU to put it back, you just hit F11, do a one-time override, and then keep going. So for this case, we just want to go into RBSU, so we'll hit the number 9, just as if we had pressed F9 during system boot, and now we go into RBSU. It looks very similar to what it has previously. When we get to G9, we're actually going to change this quite a bit, so I'm sure we'll have training. G9 will have a lot of training because there will be a lot of things that are different from the system ROM perspective. But as you can see, this is RBSU. The menus have changed a little, but the look and feel is almost exactly the same. So that's what I wanted to demo. I believe the early video support for the error message and everything will be a big help to our service organization and hopefully reduce our service costs on our servers. And that is a good case of HP ASIC engineers who design the ILO ASIC working with firmware engineers to implement something that hopefully our customers will value and will affect our bottom line.